We are live. Good evening, everyone. Welcome to the live chat for Wednesday, January 24th, 2024. We have a couple things to talk about. Will we have a winter storm? I'm going to break down the reasons why I'm a little skeptical of this whole setup, and I'm going to introduce some factors that you might want to watch and take a look at. I'm going to answer your questions, of course. But before we get to that, there's a couple things I want to touch on beforehand. First of all, I will be traveling next week for various reasons. So, with that, we won't be having a live chat next week because jet lag is not fun. And also, video discussions on Monday morning might be a little tough. Definitely Tuesday, Wednesday, back on Thursday. So just so everyone knows that. But we'll get all that together and we'll get that all taken care of. So there will still be text discussions and all that good stuff. So, and if you have questions, you can always drop an email. I'll be happy to answer them and all that good stuff. So, got that out of the way. Now, of course, there's a question of the model guidance. There's a lot of stuff floating around social media. Everything from winter's canceled to, hey, there's going to be a blizzard on Monday. I literally got 2 emails of those two topics back to back. And so it's kind of fun to see how everyone's looking at various models and then how they go from one extreme to the other in a very, very short period of time. And this email was sent within 30 minutes separation by the same person, which I thought was comical because first they complained about winter canceled, and then they sent me an email about a blizzard on Monday morning. So that's always fun to always get that. I'm like, well, you just said that winter was canceled, so. But I digress. So let's take a look at some of the information, and then we'll dive into the questions. Of course, the way we always do this, just in case you're new, we answer all the questions in the premium live chat because they're premium members. And then after that, we check out what's going on YouTube and what's going on X, in which I got my phone up to see if I can actually see this myself and see the questions being asked as well. So I have that here as well, so we'll get to that. And hopefully that works out, and we'll see how that plays out. So let's take a look at some of our data. And we start first with the observations. I want to really focus in on the fog threat, especially if you're traveling tomorrow morning, if you're going to rush hour, all that good stuff. The fog is going to be an issue for this morning and for this upcoming morning and Friday morning as well. And the reason why is because we're melting this snowpack and the ground is thawing at the same time as temperatures are in the 40s right now. So you have a lot of dense fog, reducing visibility below a mile. Here in, let's see, Mount Holly, we're looking at visibility at a quarter mile, which is not good. Around Long Island, around Farmingdale, 2.5 miles. So you can see the threat here. And then we also have some areas of rainfall. The good news is that this rainfall is not heavy enough to produce any flash flooding. So that's certainly at least a good part of this news. But if you're traveling tonight, if you're traveling tomorrow morning, take some extra time because the visibility is not going to be so great. And this is all driven by a maritime air mass that's invading the region that's behind this stationary front, and then the tropical air mass is back here, and then another tropical air mass is back here, and it's all lifting northward, pushing into our region, leading to waves of rainfall. And then we have our next storm. You can see at 850 millibars that warm air surging right from the Gulf of Mexico and surging right into basically New England, driving all the cold air out. So all the cold air is being driven out, which is typical of an MJO 4 and 5. So just keep that in the back of your mind. So we have this set up here with this warm air transport. And you can see in the upper level pattern here, a nice robust trough here over the plains, a nice ridge axis over us, and then the moisture transport driving in. And the key theme over the next 10 days is this upper level low just kind of locked up here in Canada, and this feature heading towards Alaska, and this feature dropping down towards, well, basically to the south of Greenland and to the north of Quebec. So when you have this signal, this usually slows down cold air transport and locks up your coldest air in northern Canada. So this theme is already here. Okay, so that's an important factor to consider when you're looking at the guidance over the next 3, 4, 5, 7, 10 days, right? So when we take a look at the water vapor satellite picture, you can see the moisture transport, the connection to the tropics coming right out of the tropical Pacific, cutting through Mexico and heading right up towards us. So there's plenty of moisture to work with. Subtropical jet stream is more than energetic. Polar jet stream, though, is locked up. So we have this pattern in place. And one of the key things I like to look at if I'm forecasting for any type of winter storm or pattern change is not so much what's the forecast out here, but what's the forecast here, right? What's the forecast a couple of days out? Because look, there, as you can see here in the forecast for the Arctic Oscillation, there is quite a bit of volatility here this far out. So, I could certainly see this dropping down towards neutral or going negative as we go forward over the next couple of days. So I don't put a lot of weight in my forecasting in the data out here. I keep an eye on it, but I don't get too worked up about it. But when I study this data here, this usually has a little bit more confidence, agreement. And at least through the 29th at least, this is a raging positive Arctic oscillation. The EPO, neutral. North Atlantic oscillation, positive. No sign of any type of negative feature, no drop. Then the PNA. The PNA is where we jump into this positive. And this features what's kind of driving the overall storm potential to begin with, right? Where you're getting this spike in the Pacific North America oscillation. And what that basically represents is a ridge in the west. So you have this spike setting up, this ridge in the west. So you see the potential for, at the very least, a storm. But the other indices would suggest, well, this is probably going to be a fast-moving storm. Not really a lot of support to slow it down. It doesn't have much support to keep cold air locked in. And there isn't much support to allow for rapid intensification. That's the overall theme, typically, when you see these indices. So that's the background, right? Now, take a look at the MJO. The MJO background is 4 and 5. Now, remember, there's usually a lag between what you're seeing here and then what's actually impacting your pattern. Because what's happening in the tropical Pacific doesn't just flip over the next day into North America. So you have to take some time. So the MJO phase right now that's driving this pattern is more like 4 going into 5, like this right here. And this is the rest of the week into early February right here. And then this is February here. Now, to give you guys a little bit of hope here, the MJO and a variety of models are either going into a neutral state or going into a phase 8 in this time period. Neutral or phase 8 is fine if you're looking for your typical El Nino February, because neutral means that El Nino stands out, and phase 8 and 1 means that El Nino pattern is enhanced. So either one will work in this scenario to get us back into our active cold weather pattern, assuming that the evolution of the tropical convection really starts to fire up around the dateline. Notice right now, not much convection. And then again, another warning sign here, right? So when I'm seeing model guidance, the European, the GFS, whatever, I don't care. Pick any operational model, the icon, right? When I see a storm signal in an environment that is very unfavorable, my BS detector starts to ring like crazy, because this is really has to be a thread the needle type situation then, because everything else argues against it. So I don't have the convection. I don't have the blocking. I have an active pattern, and I have a brief spike of the Pacific North Atlantic Oscillation, or a ridge in the west. Just to kind of pull my point here, the polar vortex for the next 24 hours is as consolidated as you could have it in the winter. So again, this would slow down polar and Arctic air masses from dropping south. But to give you guys a little bit of hope as well, because winter is not canceled, there's also strong support for a stretching of the polar vortex. And as I discussed in my premium discussions, the key for February is the position of the upper level trough over the Pacific. If it's over Alaska, game over. If it's over the Aleutians, game on. Simple as that. I'm going to make it as simple as that. If we get an upper level low locked in over Alaska, forget about it. It's going to be mild. If we get that upper level low and trough centered over the Aleutians, game on. That allows polar and possibly even Arctic air to bleed into the northern mid-Atlantic and interact with an active subtropical jet stream, and opens up the potential for a weak North Atlantic oscillation, but nowhere near as robust as what we saw in January. So when we take a look at our overall pattern here, what sets up even the potential for this storm? Well, 90 hours out, this is the European. This feature right here has to keep this feature from getting any further northeast. So basically, it acts like kind of like a pseudo block. And that shows up in the European, the GFS somewhat. But notice the GFS, look at the difference here. The European tries to push down. Notice this push down, where the GFS is a little bit flatter and a little bit more focused towards the Atlantic Ocean. Those little details, those little tiny details, you might be saying to yourself, Stephen, why does that matter? Those little tiny details are going to make all the difference in this type of storm. Because in this type of storm, you need to have all the timing work out, all the cold air transport to work out, all the timing of intensification of the low pressure systems at every level to work out, to support what the operational European guidance, which is what I'm seeing all over the place this afternoon, and the European ensemble guidance to some extent to work out. Okay, so that's how much of a thread the needle type scenario we have here. On the GFS ensembles, again, a little bit further north, a little bit weaker trough down towards the Ohio River Valley. And then the European ensembles has a nice trough here. Again, this features a little bit further north, so your cold air transport is going to be delayed because of this. Meanwhile, your Western Atlantic ridge here, it shows up on all the guidance. You take a look at all this. But notice a very important feature here. See this upper level low here? This is pressing down on this ridge significantly. And if this is a little bit more robust than what we're seeing right now in the guidance tonight, then this ridge gets knocked down. This trough isn't as robust, and you get a much weaker storm. So when I look at this, and then I look at the overall theme that we have, positive oscillations that we don't want. We have not much in the way of support of tropical convection. We have the wrong tropical forcing signals. We have the wrong stratospheric signals. All these signals are no. That should be a warning sign saying, this might be an error on the European. So, where can we find the error? Well, I take a look at the upper level winds, and again, this is a pretty good idea. I have no problem with this. A trough coming in, good divergence in diffluence, plenty of moisture being drawn northward. Game on. I totally agree with that. Again, as the storm pivots and moves through, goes into a neutral trough, sure. Under the larger trough, makes sense. Sure, you got the wavelength set up in the subtropical jet stream to set up the sine wave. I have no problem with that. Where it gets a little funky is when I look at the 850 millibar winds. And I start seeing these bullseyes showing up in the wind field. And this bagginess showing up here. And when I start to see that, it starts to tell me, are we looking at a convective feedback error? I was like, all right, let me keep on diving in here. Because that looks a little funky, sure. But maybe it's just a feature where the model is trying to develop this 850 millibar low, and that's why we're seeing these little bursts and winds. So this would make sense with a strong 850 millibar low, but also this is another warning sign saying, wait a minute, something doesn't make sense here. This is a strong easterly wind on this 850 millibar low while you have cold air transport dropping towards the coast. Okay, how does that work out? So it probably has to do with some sort of adiabatic cooling, right? Where your heights are rapidly falling. So again, warning signs. Not something where you throw the model out or anything, but certainly something to say, this may be a little questionable. So now let's take a look at 500 millibar PVA. And up to this point, up to 102 hours, I have no issues. This makes perfect sense. Sure, you got a trough going from a positive tilt to a neutral tilt. You have divergence and diffluence on the east side, strong PVA, periods of rain, not an issue. Then we get to Sunday night into Monday morning, and at 500 millibars, we get this upper level low forming right over. Now, again, a lot of bagginess here. You get this crisscross here. Like, that doesn't seem right. That seems like a bit of an error. You have this low pressure system that is rapidly intensifying. So this would explain how you get the rapid cooling, because what you have is rapid rising air. So that cools the environment and allows for cold air to be developed under the upper level low. But does it fit the rest of the pattern? What would cause this to intensify like this? And why is it focused in this direction here? And why is it that we had previous guidance that was baggier than this? And again, at 850 millibars, you kind of see this signal as well. Like, okay, you got this rapid intensification. I get it. But what's causing it? And this is where we go into the 850 millibar temperatures. Now, again, just to kind of step back, the heart of your polar and Arctic air is up here. So everything has to be reproduced here. So your core polar and Arctic air mass is up here. And as I suspected, when I got to 850 millibars, this isn't seen on the icon on the GFS. The Canadian, so-so. But I saw this signal here. And typically when I see this signal here, it's usually a representation of some sort of convective feedback error. And so you get this rapidly intensifying low pressure system when the rest of the environment doesn't really work. So what I just showed you right now, and the reason why I want to show you this, is that it's not just pick the model that gives me the most snow, because that's what I'm seeing everywhere. And as you guys know, I would love to have a major winter storm, because then my winter forecast looks great and I go, yay. You know, even though I'm traveling, it's still not the best situation for me, but still, you know, I still love snow. But when I see all these warning signs, it makes me say, what is going on here? Is there something wrong with this guidance to produce this type of result? Because as a trained meteorologist, the first thing I say to myself when I see all these other factors is something doesn't seem right here. Something's off. So we have this signal here. Now, this is something I want to ask you guys, and you could think about this. How many times have you seen 850 millibar temperatures crash in a MJO phase 5-6 from +4 to -6 at 850 millibar temperatures while all your precipitation is still in place. I can count my finger once, and it was actually during that Halloween storm when me and my wife were dating. That was the one time I saw this where it crashed, and it wasn't even a 10-degree crash. It was more like a 6 to 8-degree crash at 850 millibars. But basically, we're going in the model guidance from +4 to -4 in less than 6 hours. And it's all driven by adiabatic cooling, rapid rising in the atmosphere, and for a low pressure system that doesn't have any other support for this type of intensification, and appears to be driven more by convective feedback and rapid intensification of the 850 millibar low than actual favorable pattern. So that's why you see the difference between the GFS here. Here's the European, right? You see changeover on the coast here and heavy snow over northern New Jersey, bleeding into central New Jersey, and a low pressure system is just bombing out. And here's all your convective precipitation out here. Let's take a look at this. It goes from about 1,000 millibar low, 1,002 millibar low, to 997, 992, 989, 987. So that's like a rapidly intensifying storm in a positive NAO, positive Arctic oscillation, positive EPO oscillation environment, driven solely by a brief period of a positive PNA. I need more data to trust that based on my experience. So when I take a look at the GFS and see what it did, and again, there's no doubt there's going to be a storm. I have no issue with that. And also for you guys in the Poconos and Catskills, definitely I like the idea of rain changes of snow and some accumulating snow. Maybe not a foot, but certainly accumulating snow. I certainly like that. I like the idea of rain changes of snow as the storm exits, but we're talking about snow showers, not accumulating snow, because ahead of this, remember, we're going to be in the 40s and 50s. Then we cool down, and we also are not expecting any type of moderation of this polar air mass coming in. Some issues there. So I actually like what the GFS did here in the 12Z, and the 18Z did the same thing. And what it did here at 500 millibars makes sense with the overall pattern. An upper level low marching in, it gets weakened because there's a strong upper level low to the north, which usually causes a shearing effect, not an intensification effect. And you have other short waves coming in from the polar jet stream as well. So that makes a whole hell of a lot of sense. So mark this down as a historic event. The GFS makes more sense than the European in this scenario. Yes, I said it. It does. It just does. This is what I would expect in phase 5, 4, 5, and 6. Progressive, open wave, keeps on moving, cold air is limited. That makes a heck of a lot more sense. And the 850 millibar representation here makes a lot more sense. Like cold air comes in at the end of the storm, interior snow. Makes more sense. So I'm highly skeptical of this scenario as a result, based on what I'm seeing. So that's kind of where I stand here. So the overview, winter's not canceled. February still looks pretty reasonable. I think there's still some activity we'll have to watch out for. I think that winter potential through February is very much a possibility. Whether it gets into March, I'm a little skeptical of, but we'll keep an eye on it. but we'll continue to watch it and see how it evolves. I need a lot more data, and we'll get it over the next 48 hours to trust a 10-degree drop in 850 millibar temperatures in a 6-hour span under an upper level low in an unfavorable environment otherwise. So that's kind of where I'm standing now. If I'm looking for snow in this scenario, I'm looking at the Poconos, the Catskills, the Hudson Highlands, which is northern New Jersey through Connecticut, in the Hudson River Valley. Coastal plain, rain for most of the time, maybe ending as a little bit of snow as the cold air comes in. And as always in these scenarios, 5-6 days out, the cold air is always coming in just in time while there's plenty of precipitation. And as we get closer, the potential of that being a reality disappears because the timing just doesn't work out. Because when you have strong cold air transport, you also have strong dry air transport. And the only way you get that to set up is if the 500 and 850 millibar low stalls and then the storm becomes vertically stacked, which doesn't appear to be the scenario that would be possible in this setup with the Atlantic wide open. So with that, I am going to answer all of the questions because I'm sure some people are probably disappointed based on what I said. Some people say, yeah, that makes sense. So we'll see what we got here. And of course, I'll answer whatever we have here on YouTube as well. But first, we're going to hit the community chat. And then, of course, we'll talk about some of the X questions, which are always interesting. X is always an interesting place, or what was Twitter. So let's see here. Good evening, Snowboss and Card. How you guys doing? Nothing worse in winter weather than 36 in rain. I disagree. How about 33 in rain? That's worse. Because that's just mind-numbing. That's like, it's 1 degree. I just need 1 degree. And of course, my luck would be 1 degree and be freezing rain. So, let's see here. Saw that the polar vortex is really consolidated. Yep. But at the same time, there are healthy flows of air from the tropics. There is plenty of movement from the EP flux. That's why I am pretty confident in the idea of stretching of the polar vortex in February. I don't see a lot of data, though, of it stretching towards North America. So for us to get what we want, okay, we have to get this stretch towards the Aleutians to kind of set things in motion. Let's see. Also, the 250 millibar Asian Pacific North American jet is reflected at 70 millibars. Yes, it is. It actually, this year is not acting as weird in terms of the stratospheric evolution as opposed to the previous 2 years. Maybe the atmosphere is kind of readjusted with all the water vapor that was up there at 5 millibars and 10 millibars from the volcano. But this year has pretty much evolved. I know that not everyone has gotten the snow that they wanted, but as far as the ideas, talking about the QBO, disruption of the polar vortex, all that stuff, that's pretty much worked out as expected. It's just a matter that some people didn't get as much snow as they wanted. But the ideas pretty much has worked out pretty well. One thing that also seems to have been a trend with the solar cycle is that while we get quiet with a few flares, the CMEs related to them have underperformed for the most part, and in many cases either miss us, giving glancing blows, or the flares don't seem to result much. Yeah, thank God. Here's the thing with all these CMEs, right? When we have an active sun like this, if we get hit with one of those, our whole telecommunication grid is screwed. So hopefully that remains the case, and hopefully it remains that way for quite some time. Pat Conway asks, will Long Island get in the fun for Monday? I would not be surprised to get some snow showers at the end. I don't buy the heavy snowfall. I don't buy the accumulating snowfall in this setup. Now, again, that doesn't mean I'm going to ignore the threat and just say, whatever I see, I'm not going to bother. I'm going to keep an eye on it. But my professional opinion, everything I'm looking at, this looks like more to be a cold air comes in at the very end. Most of this is rain, wet ground as well, difficult to accumulate. Then the cold air comes in. It's a cold shot too. It's not anything to sneeze at, but the setup to me just tells me this is going to be more delayed, and I don't buy the intensification of the low pressure system at all at this point. Why is the back end snow with crashing temps rarely ends up working out? Based on your memory, it always takes much longer for temperatures to fall than models, as you've noticed. Why is that? Well, see, here's the thing. The models, and this is why I always laugh when someone says automation. I'm like, yeah, go for it. Have fun. The models have a difficult time with dealing with the transfer of energy, mass, and motion, right? So the models, they're getting better in handling the different orographic features that we have involved here on the East Coast, and same thing in other parts of the world as well. But there are still factors that we still struggle with. And look, I'm not saying that me as a human with my brain can figure out exactly what the speed is. But I know based on my experience that, okay, the model is suggesting this rapid cool down, but we know based on experience that that typically doesn't play out because of friction, because of timing of the mid-level lows. What happens is that because of the evolution of the storm, you're getting a lot of convective development out towards the Gulf Stream. And when you have that convective development, it leads to issues, especially with synoptic models, with a convective feedback error, because it's trying to resolve all this rising motion and the release of latent heat. And sometimes it does a good job, but most times it doesn't. So what it does is that it creates a low pressure system, 850 millibar low pressure system that develops faster than reality. So like we said with many of our storms, and when we did the live chat, right, in various storms, if the 850 millibar low is delayed, the cold air transport's delayed. So when we study storms, we always mention that. Like, yes, the rain will change over to snow. The accumulation will depend on how fast that low pressure system transfers to the coast. You know that theme. Same thing here. But in this case, it's doing it at such a rapid pace that it literally drops 850 millibar temperatures 10 degrees in less than 6 hours. I would be far more confident of something like this happening if I had a huge 50 north, 50 west upper level low to block the exit of this low, and I already had an Arctic air mass that was very close, and maybe because of the evolution of the storm, you got a little bit of warm air transport, and then the cold air came flooding back in. In this case, this cold air is up in Syracuse, and then we're dropping it down. Not something that typically happens. So, I mean, is it possible? In atmospheric science, I never say never. But, again, my BS detector's up here on this setup. Awesome discussion on how to break down, model, and analyze it when forecasting. Thank you, Card. Your winter forecast is serious jeopardy. I don't know. Okay. And I have gone over it many times. And other than December, the forecast isn't really going as you predicted. Thoughts so far? I disagree. We had the winter storms in January. We had the evolution of the cold pattern. We had the expected thaw that would be for late January. And we'll see for February. See how that works out. January, we had winter storms. Again, you may not feel like you had the snow that you wanted, but in reality, according to the National Weather Service, outside of Long Island is below normal still, and New York City is below normal, but the rest of the region's averaging near normal, and we'll see what happens. Again, as I said back in the winter discussion, this winter is pretty much going to come down to one or two storms, and whether or not they're blockbusters or not, in terms of snowfall. In terms of the overall theme of the pattern, December was supposed to be mild. That generally happened. January, we've had our warm start, Arctic blast, storm potential. Now we're heading into our relaxation. That was expected. So I'm pretty happy with that playing out. And now we go into February where we'll see whether or not, and that's where I pegged as the best potential for winter storms. We'll see how that plays out. Temperatures, I expected them to be above normal in December. Near average, I figured it'd work out for January. We'll see where we end up because part of that has to come down to what happens on Friday, whether or not we push into the 50s or 40s or 60s. Right now, that's been backed off quite a bit. So with the temperatures, we'll probably average probably close to near normal. And then February, we'll see how that works out. That's pretty much going to be the hedge right there. Was that the 2011 October Halloween storm? Yes. Was it cold enough after the cold air comes in to cause standing water to freeze? Yes. Yes, definitely. Based on what we're seeing right now, I like the cold air transport on all the models after this, like on Monday afternoon, Tuesday. It makes perfect sense. Convective feedback. All right, to make it. Well, that's a whole class. Explain convective feedback is, let's see, that took me 4 classes to go over in college, but I'll give a paraphrase. When a model is trying to forecast for thunderstorms, right? The process of that involves condensation and the development of clouds rising and the development of precipitation. And that convective process leads to a release. Now, that process is in such a small grid that it's very difficult for the models to visualize it, right? So thunderstorms develop on 8K grid, or if you're talking about TV screens, 8K, and our models work on regular HD, right? So the convective models we use, the mesoscale models, those are on 4K, so they could see it a little bit better. But this whole process and the release of latent heat, sometimes the synoptic models aren't able to handle that process. So it produces too much energy, too much release. It overcompensates. And so as a result, it alters and bends the thermal gradient. And so the thermal gradient leads to a stronger thermal gradient leads to stronger cyclogenesis or low pressure development. And that low pressure development then shows up on your model as rapid intensification. Now that rapid intensification leads to falling 500 millibar heights. That falling 500 millibar heights means more lifting. So this is how you end up where you have your precipitation showing up producing 4 or 5 inches of precipitation, or in some cases like what we're seeing now, because of the rapid drop in heights, rapid cooling happening in the atmosphere. So these signals, you have to be aware of them, and then you have to look at them and say, this might not actually work out. But you also have to keep an open mind, because can something like this happen? Meteorological law? Sure. How frequently does it happen? Very, very, very rarely. So in such a rare scenario, in an unfavorable pattern, I know people want me to say like, hey, look, we're going to have a snowstorm. I am highly skeptical as a result based on that. I could be wrong here. I could be like, it could be that this could be 1 in the 100 cases where this actually works out. But 99 of those 100 cases, it does not. So I'm kind of leaning more on the 99 rather than the 1. But of course, keeping an eye on this. Let's see here. Steve, your fog concern looks like it will turn out correct. Dense fog advisory issued for, yeah, definitely. SBC has day 4 severe threat for parts of Georgia. Seems to indicate that energy and lifting is going to be deep south and not up in our neck of the woods. There'll definitely be that severe threat setting up, and that's part of that divergence and diffluence that sets up. Severe weather during El Nino is not surprising in the southeast. We'll see how that plays out. And I'm curious to see what the 0Z guidance and 12Z guidance tomorrow does with this setup. So let's see here. Let's see what they got on YouTube. Oh, look at this. Let's see. I'm going to take the best question. I do hope it turns out like the Halloween storm. Would sea surface temperatures have anything to do with rapid intensification? Okay, so that would definitely be a factor here. Now, all right, let's just say, hypothetically, that you get that 10-degree drop in 850 millibar temperatures, which means you have rapid cooling going on at the coastal plain, where we're dropping from the 40s into the 20s in a 6-hour time period. So what you've done at the surface is that you enhance the thermal gradient, because your sea surface temperatures are in the 40s and 50s. You've enhanced the thermal gradient in a 6-hour time period from 1 degree to 20 degrees. So when you have a 20-degree gradient pop up, that causes very strong frontogenesis. Okay, so now you have this frontogenesis occurring, where the warm air is trying to invade the cold air. You're getting the lifting involved. Then you enhance the low pressure system development as a result, because at the same time while all this is happening, you still have strong divergence and diffluence aloft by the upper level winds. So what ends up happening is that the cold air crashes down, the warm air tries to work in, you're getting all that lifting, it intensifies the low pressure system and allows for expansion of the heat of the process. So yes, it would definitely, if this actually happened, it would definitely enhance the development of the low pressure system because of that gradient. March 1st, 2nd, 2009 storm would be an example. That was a unique storm. The EPO was negative, though. So it was definitely a thread the needle. The Atlantic was not favorable. In this case, the Pacific and the Atlantic isn't exactly favorable. The only thing that is favorable that's driving this whole thing is the PNA. But yeah, that was definitely an unfavorable pattern. Absolutely. It was an unusual one, to say the least. Only other example of rapid crashing temperatures I could think of is a surprise snowstorm we had in November 2012, right after Sandy. Yep, that was a unique one. And part of that, I have to wonder what had more to do with some of us having a lot of missing data involved there. The GFS could have feedback error, but the problem is that the GFS exhibited no symptoms of feedback error. So what you would have to do for me, Dylan, is, I know that you're in the Discord chat. This is what you would have to do. You have to find for me, I'm going to give you a job to do. Okay? Because I know you don't like the GFS because it doesn't produce the storm you want. So if you're going to claim it could have convective feedback, what I want you to do is find the clues for convective feedback. Is there any bullseyes showing up in the precipitation shield or in the temperatures? Is there any unusual rapid lifting or augmentation of the wind field? So that's what I want you to do, Dylan. I want you to go in and find that to make the claim that the GFS has that type of error. Because as it stands right now, when we look at the temperature field, it shows no such error of that at all. Let's zoom in. There's notice in this same time period, there's no popcorn signals here at all showing up. Your cold air is lagging behind because, again, all your cold air is locked up in Canada, which makes sense with the current Arctic oscillation. So what you would have to show me in this scenario is some sort of signal of convective feedback. And look, I am no fan of the GFS, but look, there's no convective feedback here. Here, it'd be a good idea if I could show you this. There you go. There it is. So here's the GFS for the same time period as the European. There's no sign of convective feedback here. None. So I need you to show me that. Again, like I said, I'm not the biggest fan of the GFS, but it is what it is. Let me go take a look and see if there's anything going on in X. Let's see. Again, should I get milk and bread and eggs and then make an awesome French toast? Let's see here. Oh, yeah, I was able to get it up on here. Let's see here. When will we know if winter is over or not? I would say I always put an end of winter at March 15th. That's usually a good idea. So March 15th is usually my cutoff where I'm like, all right, that's it. We're done. Regardless of the year, just because the sun angle is much higher by that point. Usually your polar vortex is starting to collapse, and your polar air masses start to weaken. That doesn't mean, look, we've had cases in April and whatnot, but usually March 15th is my cutoff. And then we just keep an eye on some unique, weird situations.
Rainy season.
Exactly, rainy season. And also planting season. We put in some trees and stuff. Models have struggled this year with anything more than 4 or 5 days out. Is there a theme driving this? Models have significantly improved. And there are some amazing data and capabilities. But we need to remember there's limitations. And the problem is that you have some people running out there making statements of guarantees and snow maps for model guidance, and in some cases using climate model guidance for snowfall forecasts. And the problem isn't the model. The problem is the models are being used improperly for what they're meant to be used for. Okay? You have to use the right tool for the right situation, and you have to use it properly and understand what your limitations are as a scientist in understanding the pattern and stay within that. When I was younger, in my 20s, my ego would get the best of me because I wanted to be the first and I wanted to be the best because I thought that's how to advance in my career. And that was a mistake because it doesn't matter if you're first with a forecast if it's wrong. And you'll never be best because you will be wrong because this is forecasting chaos. So you will make errors, you will be wrong, and the best thing to do is learn from it. Now in this scenario, I look at the models and I compare the environment that I'm in. And then ask myself, is this a reasonable solution based on my experience? With the caveat that, look, atmospheric meteorology, weird stuff can happen. Maybe the European scores a real win here. But while I will be keeping an eye on it, I have very low confidence that what you're seeing right now in the European is a realistic outcome. When will the NAM be in range? The NAM starts out, let's see, I think, what is it, the 12 kilometer goes out to 84 hours. I like to use the NAM under 60 hours. You can get out to 84, just like you could use the GFS out to 360, whatever. But I don't like using the GFS out that far. I don't even bother looking at the GFS out that far beyond 240. So when I look at the NAM, I start at 60, and anything beyond 60, I'm like, yeah, that looks nice. Maybe I'll use it as a screenshot or something. But I wouldn't use it for forecasting. Let's see. So we'll know about the setup for Alaska and the Aleutians, all that stuff, in the next 10 days. Exactly what's going to be evolving here. So right about the time when I'm writing my forecast for February, I'll know exactly what to expect. So basically next week. The GFS is really not a good model to look at. Now, is the GFS not a good model to look at because it's not producing the storm you want, or because of the model? Now, look, like I said, I am in no way, shape, or form like cheerleading the GFS as a great model. It's not. But the question is not whether or not the GFS is a great model. The question is what's a more realistic solution in the pattern that we're in and environment we're in. So when I consider that factor and look at the data here, look, this depiction, if I'm as a forecaster, what I'd probably do is I'd probably make this a little bit stronger, make this tilt maybe a little bit more neutral, so that way you get more rainfall, because I think that the depiction of the precipitation is probably too low here. I think this is a little bit too disorganized, but I like the evolution of the mid-level pattern. So you don't just take the GFS and say, I'm going with the GFS, copy, paste, delete, go. You don't do that. I look at the GFS and I say, okay, this environment looks more reasonable. I have to tweak this. I have to fix the 850 low. The moisture transport's a little too low. Got to fix that. And adjust the development of the low pressure system. And I'll do that based on what I'm seeing with the ensemble guidance. Mix all that together, spin it up, throw it in the oven. There you go. There's my cake for the forecast. So you do not just take the GFS and say, copy, paste GFS. You do not just take the European and copy, paste European. You look at the overall environment. You look at what the tools are showing you, and then you take your experience and then you create your forecast. Snow chances in central PA, they got a shot. They got a shot depending on the evolution of the 850 low. I certainly like that better than in Monmouth County, I'll put it that way. Let's see. We're getting all these in my backyard stuff. So let's see. We got all the questions answered in the chat room. And, I think the next live chat, I think what I'm going to do is I'm going to pull up the winter forecast. And we're going to go over what I said for January and compare it. And then I think that'd be a fair way of going about going over the forecast and see where we're at. We'll see what we're doing for February. And of course, by that time, we'll be in February and we'll talk about what to expect for the rest of the month. And the premium members all have the February forecast already out. So you can definitely check that out. And we can start making comparisons. I got personally, what I've liked in that January time period, more widespread heavy snowfall, like a 10 to 20 inch type storm. Absolutely. But I never guaranteed that. But would I have loved to see it? Yeah. Then my winter forecast would really look great. But the overall themes and the evolution of the pattern, I'm pretty happy with. I never guaranteed that anyone was going to get the specific snowfall amounts. But I did promise that, look, there'd be plenty of potential. And that's essentially what we're seeing. El Nino Februaries have had some big snowstorms. Yes, they have. They definitely have, which is why I will not let my guard down in February when it comes to winter storms. I've learned that lesson the hard way. That is for sure. Very biased model, in my opinion. Which model? I'm guessing the GFS. Well, there's a lot of. Here's the thing. Models are there's a tons of different bias. Let me pull up. Okay, so let's talk about model bias. So GFS definitely has a cold bias, um, and it tends to have an issue with phasing short waves. Doesn't do too well with Arctic short waves. The European has issues with short waves that come out of the Pacific, especially subtropical from the subtropical jet stream. European also at times can have a overphasing, especially in the 5 to 7 day period. It is one of the better models. It usually ranks the highest, but it does have its when it has its biggest errors. It usually comes from overphasing and too strong cold air transport. The Canadian tends to have errors with developing coastal low pressure systems. It hangs back the primary load too long because it doesn't do a good job with transfer at 850 and 700 millibars. It also tends to have an issue with hurricanes as well. I think it has something to do with latent heat energy, but I'm not entirely sure. The Icon has errors because of the poor sampling that it has and the grid scale it uses. It's improved, but still lags behind. So it doesn't handle cold air transport very well, and warm air transport as well either. The NAM tends to have too much convective feedback error. For a couple models, there's always one model running a storm that's just completely ridiculous. You could always guarantee it. Let's see, the HRR has a difficult time with transition from rain to snow. Sometimes it does it too fast and doesn't handle the dry air transport well enough. I can go on. Any model you can find, there is a ton of error. So there's always error. So you always have to be mindful of that. The GFS also has massive convective feedback issues. Absolutely. Especially with tropical systems. It always tries to produce a hurricane every time. From May all the way through November, you can guarantee it's trying to produce some sort of hurricane moving up the East Coast. But this is why you always look for it. Like, where is there convective feedback? In this solution, in the 12Z guidance, there is no sign of convective feedback error. Now, that might not be the case for 0Z when it comes out. It might not be the case for last night's 0Z. But in this model run, for the signals you look for convective feedback, it doesn't show up there. But I also don't like the way it handles the moisture transport either. So that's why I would say that the rainfall for Sunday on the GFS is too low and it breaks it up too fast. So I wouldn't go that route either. Let's see what else we got here. Model initialization error, that could be a variety of different things, okay? What you basically do, all the weather offices throughout the world, right? They issue their data, right? Their observations. They send up weather balloons. We have airlines that report information. We have satellite data, radar data. All that data gets put into a database. And sometimes, not always, but sometimes, that database is corrupted. There could be a bad observation. There could be missing observations. Satellite data may have been disrupted. Variety of different issues. And even with that, there could be issues with how the model initialized that data. So, for example, if you have a line of thunderstorms coming through, it may not be able to handle that transition very well and that latent heat release very well. So it starts to create errors that snowball on themselves. So that's an example of that. Yeah, again, I'm not supporting the GFS. I'm just saying in this, like I said, in this scenario, there is no convective feedback error. That's it. I know that everyone wants the European to be right. And it might be. But again, I'm giving you the warning signs like don't be surprised if tonight's 0Z guidance has nothing like this and it's just snow in the Poconos and that's it. Don't get upset at me if that happens. So let's see here. I think I answered all the questions, everything on X. So with that, it's 9 o'clock. I'm starting to lose my voice. We will continue to keep an eye on this storm. Of course, I'll have videos tomorrow on this, and we'll see where the 0Z guidance went and see how that evolved. We'll take a look at all that, and I will, of course, have updates now all the way on through the weekend. By the way, this storm could actually have a pretty big impact with the Baltimore Ravens and Chiefs game on Sunday, where the Chiefs will win. Thank you very much. And we'll have heavy rainfall, so that should be interesting for that game. So that should be pretty fun. And also, during that same time period, let's see here. There's a chance we could get some rain coming in for around California. We'll see if that still plays out. But certainly an interesting storm for the Chiefs game. So that should be fun too. Thank you again for following and for coming into this video and the live chat and everything. I really appreciate it. It's been a blast, and I will see you in February. In the meantime, stay safe out there.